Alright, let's look at solving a system of equations, two unknowns, using the substitution method. To use the substitution method, we want to take one of these equations and solve it for one of the variables. And you can see that the easiest thing to do is solve this second equation here for x, because all we have to do is move the 2y over. So I take x minus 2y equals -3, and I'm going to add 2y to both sides. So I get x equals 2y minus 3. Now we want to take this 2y minus 3, we solved this one for x, the second equation. So now I want to take this and plug it back into the first equation for x. So that's going to give me 5x, and in the place of x I'm going to put 2y minus 3. So times 2y minus 3 minus 4y equals 9. Now I have an equation just in terms of y, so now I can solve for y. So I distribute, so I get 10y minus 15 minus 4y equals 9. Combine like terms, I get 6y minus 15 equals 9. Add 15 to both sides. I get 6y equals 24. Divide by 6. I get y equals 4. Okay, now I need to figure out what x is. So I could take this y value and I can plug it back into one of these. But the easiest thing to do is take the 4 and just plug it in here for y, because this is already solved for x. So I have x equals 2 times y, and in the place of y I'm going to put 4. So times 4 minus 3. So I get x equals 8 minus 3, x equal 5. Now my solution is 5, 4. X is 5, y is 4. Now I'll write that as a point, xy. So my solution would be x, y. And there's my answer. And what this is a point where these two lines intersect. And here's the graph of the two lines. And you can see they intersect at the point 5, 4. And there's the point where they intersect. 5, 4. Let's take a look at another one. I'm going to take one of the equations and solve it for one of the variables. And you can see the easiest is to solve for y in the second equation. So I've got 2x plus y equals 1. I'm going to subtract 2x to both sides. So I get y equals negative 2x plus 1. So now I take this and I substitute it in to the other equation for y. So that gives me 3x plus 2 times y, and in the place of y I'm putting negative 2x plus 1 equals 4. now I have an equation just in terms of x. So I solve this for x. I get 3x minus 4x plus 2 equals 4. So I get negative x plus 2 equals 4. Subtract 2 to both sides. I get negative x equals 2. Divide by negative 1. I get x equal negative 2. Now I substitute the negative 2. I can substitute it in here, and that will give me y. So I'm going to plug negative 2 in for x. So I get y equals negative 2 times, and in the place of x I'm plugging in negative 2 plus 1. So I get y equals 4 plus 1, y equals 5. So my solution is the point negative 2, 5. Alright, let's look at another one. Here, this first equation is already solved for x. So I can just take this and plug it into the second equation for x. So I get x, which I'm going to plug in 9 minus 2y. 9 minus 2y plus 2y equals 13. So combine like terms, I get 9 equals 13. And you can see here the y's went out and I'm left with just 9 equals 13. Well, this is not a true statement. So I have no solution. And these have no solution, and if we take a look at the graph, we can see that the graph of these two lines, they're parallel. They'll never intersect. So we have no solution. Alright, let's take a look at one more. Okay, this one is already solved for y, the first equation. So I'm going to plug this in the second equation for y. So I get 15x minus 5y, and in the place of y I'm plugging in 3x minus 2. Equals 10. So I solve, I get 15x minus 15x plus 10 equals 10. Combine like terms, I get 10 equals 10. So the variables went out, like in the last one, like in this problem that we worked. So now, but the difference is, here I have a true statement. So I have an infinite number of solutions. And if we take a look at the graphs of these two, you can only see one line, but this is actually a line on top of another line. They have an infinite number of points in common. So the way I write this, the way I'm going to write my solution is, you can see here that one of the solutions is x equals 2 and y equals 4. So when x is 2, y is 4. And also when x is 0, y is negative 2. When x is 1, it looks like y is 1. And when x is 3, y looks like it's -7. So y depends on what x is. So we need to let x be all the real numbers and take all the real numbers, plug it in, and that will give us our y value. But we wouldn't be able to do that. So what we do, instead of plugging every x value in, we just say let x equal k, where k is any real number. Okay. So if x is k, we have our x value here of k, and k represents any real number. Well, how would we find our y value? Well, we would take k and plug it in for x. Okay, just like we did in this problem. See, x was -2, so how did we find y? We plugged it in, and that gave us our y value. So the same thing here, we plug k in, so y is equal to 3x, and x is k, so 3k minus 2. So we write our solution as a point xy. So x is k and y is 3k minus 2. And there's our solution. And that's all of solving systems of equations using substitution.